Hello. I'm going to talk to you briefly about two variable statistics, some vocab, and some definitions. So, this goes with the Google Doc that you will find in Canvas, and I would recommend that you fill this out while you watch this video. You can pause this video and watch it as you fill out the definitions. Okay, so just a quick reminder from our very first unit way back at the beginning of the year. We've looked at one variable data. So when we are looking at when we're looking at data that only has like one number that we care about, we're not comparing it to anything but itself. We use one variable data. So time spent reading of like maybe a class. You can use a box plot to describe that. If I asked you how many minutes does it take you to eat breakfast in the morning, we can compare those values against each other, or heights of trees in the histogram that you see right there. But our new unit is going to use two variable data. So this is when we have two things that we're comparing against each other, and we are going to have them plotted either on a scatter plot, which you'll see on the left there, or a bar graph. And it depends on if the data is quantitative or qualitative. So the scatter plot on the left, you'll see that is what we call quantitative data, because we've got two different things that we're comparing here, and we've collected data in two different ways. And then on the right, you'll see what we call qualitative data. So that is when we don't have necessarily two sets of numbers we're comparing, but we've got a category and we are comparing the data inside of those categories. So if you see something that is categorical, that's qualitative data. And then if you see two sets of numbers that we're comparing, that's going to be quantitative data. So here's another example of a scatter plot. So automatically when I see a scatter plot, I'm thinking quantitative data. And this is a series of people, and we measured their heights and their weights. So you can see that height is on the bottom and weight is on the side. So height, in this case, is what we call an independent variable. Okay? That is the thing that drives the other piece of data. The taller you are, generally, the more you're going to weigh. Now, obviously, your height doesn't automatically determine your weight, but if you're healthy and you're tall, you should have more weight than someone who is short and is also a healthy weight. So, height is what we call the independent variable, and weight is what we call the dependent variable, because the weight depends on your height. It's not the other way around. If you weigh more, you're not necessarily going to grow more. But if you grow more in height, then your weight is also going to grow with that. Okay, so we're going to talk really quickly about correlation. Okay, correlation means that there is some sort of relationship. Okay, that's a good word that also represents correlation, relationship. In this scatter plot, you'll see that as people get older, they tend to have higher earnings. Maybe they've been working a job for longer and gotten more raises. Maybe they've studied more in their field, so they get a higher wage. but there is some sort of relationship here. I can see that the data is kind of moving up as it goes to the right, meaning that there's a relationship going on here. And yet again, in this case, age is independent and earnings is dependent, because you're not going to necessarily age more because you earn more, but as you get older, you tend to earn more at your job. Now, causation means that the dependent variable, how much you get in earnings, completely depends on your age. Now, that's not necessarily what's going on here. We see there's a correlation. We see that there's a relationship, but causation means age causes you to have more earnings. Okay? And that's not necessarily true. Okay, now here's another example here of positive correlation and negative correlation. And this really only applies to scatter plots, as you see here, okay? If we've got a positive correlation, it means as x gets larger, as we go from left to right, our data is going to move up more, or it's going to go up on the y-axis. You can see that that line is going up as we go from left to right. That's what we call a positive correlation. And on the right, in the other scatter plot, we see that as we go from left to right, as x gets bigger, y is actually getting smaller. That is what we call a negative correlation. So if the slope is positive, like on the left, it's a positive correlation. But if the slope is negative, as we see on the right, it's going to be a negative correlation. So, with these relationships, we're going to do what's called a line of best fit, okay? So that means we're going to try to put a line kind of in the middle of our data so that we can show what the relationship is, but also maybe I want to predict sales at 20 degrees Celsius, and I don't have a point there, but if I put a line of best fit, I can use that line to help me predict that it's going to be about $450 in sales. This is most likely ice cream sales versus the temperature outside. So having that line of best fit, it doesn't necessarily fit with all the data, meaning it doesn't go through every single point perfectly, but what it does is it gives us a good reference for the relationship going on here. You can also see that this is a positive correlation. The warmer it is outside, the more we're going to sell ice cream. And the slope of that line is the relationship between the temperature and the sales. So I can see that if, like, every 2 degrees it gets warmer outside, I can predict that I'm probably going to make, I don't know, about 60 or 75 more dollars. So that slope relationship becomes very important because it will tell you, oh, I need to make, $500 today and it's only 18 degrees outside. Maybe if it gets, 4 degrees warmer, I'll be able to hit that goal. Okay, and the last thing I want to talk about is what's called an outlier. So you can look at these points and you can see, oh, there's like definitely a relationship going on with the first 7 points. It would be really easy to put a line of best fit through there. But that 8th data point that we're seeing, that for some reason is really causing our line to be completely off of what we would have. Now, a lot of people like to ignore outliers and show a strong relationship, but it's not good mathematical practice. We need to include all of our data points, even if one is incredibly influential, like data point 8 here. Okay? So even though it'd be really easy to draw a nice straight line through points 1 through 7, because we've got that outlier, data point 8, it's going to really change our line of best fit in this case. Okay, that's it. If you have any questions, I would suggest you go to office hours with Ms. Mahoney or me, Ms. Bobel, and get some clarification on these definitions. All right, we'll talk about this more next week, but I hope that was clear enough for everyone.